All right, so let's look at average cost functions. This is a little bit something you might see in calculus and all that, and applied calculus. So companies plan to manufacture wheelchairs that are light, fast, and beautiful. The fixed monthly cost will be $500,000, and it'll cost $400 to produce each radically innovative chair. So write a cost function to produce X wheelchair. So I'm going to call it C of X equals. Now, this is a straight linear function because you've got this flat fee of 500,000 and plus this $400 to produce each chair. So you could say 500,000, the flat cost plus 400 times the number of chairs you produce, so 400x. Now, one thing an application that you kind of take off of this is that brings into rational functions is you do an average cost function. So an average cost function means like if you're taking the average of like 5 tests, let's say you took 5 tests and you take the average of 5, you'd add up the 5 scores and then divide by the total number of tests, divide by 5. So when you're doing the average cost function, you'd find the total cost, you add up all the costs and divide by the number of wheelchairs you produce. So my average cost function, C of X, I'm going to put a bar over the C, equals 500,000 plus 400x divided by x. Okay, so if I produce 20 wheelchairs, it'll be how much it costs divided by 20, and that give me the cost of producing the 20 wheelchairs. Okay, find and interpret the average cost functions for 1,000, 10,000, 100,000. So C bar of 1,000 is equal to 500,000 plus 400 times 1,000 divided by 1,000. Okay. C bar of, and I'm going to go ahead and write these out, 10,000, 500,000 plus 400 times 10,000 divided by 10,000. C bar of 100,000 is 500,000 plus 400 times 100,000 divided by 100,000. Okay. This is going to give you, and you're going to see kind of we're going somewhere with this, and we'll talk about that. So let's go look at this. I'm going to put parentheses on the top, 500,000 plus 400 times 1,000 divided by 1,000. Okay, so it'd be $900. So it would basically, I'll kind of explain that in a moment. Let's go to 10,000. If I want to insert a number, second delete, $450. And 100,000. $405. All right, I didn't give myself a lot of room here to interpret, so I apologize for that. So $900, what does this mean? Okay, so this means the average cost of um, producing or manufacturing 1,000 wheelchairs would be $900 per chair. I'm going to say per chair. I just don't have enough room. Okay, so basically what that means is if I produce 1,000 wheelchairs, it's going to cost me around $900 per wheelchair to produce, or $900. It's going to cost me $900 for each chair that I produce. That's going to how much it's going to cost me. So now, what is on this one? If I produce 10,000, the average cost producing 10,000 wheelchairs would be $450 per chair. So that's a lot cheaper. So if you produce more chairs, okay, the cost per chair is gonna be a lot cheaper. Okay, why? Well, basically you're splitting this flat fee over a larger number of values. That makes it a lot better. And so the 100,000, the average cost of producing 100,000 wheelchairs would be $405 per chair. Okay, and they're trying to lead you to somewhere here. Okay, they're trying to lead you somewhere, and we're going to talk about that on D. What's the horizontal asymptote for the graph for the average cost function? Okay, describes what it represents for the company. So the horizontal asymptote, I'm going to look at this, 500,000 plus 400x divided by x. I'm going to look at the highest power at the top, 1 and 1, it's right here, it's a tie. So I'm going to do the leading coefficient at the top divided by the leading coefficient at the bottom. Now, the leading coefficient is not 500,000 because that's not the number in front of the highest power. It's 400. So it'd be y equals, or I should put c of p, or c of x equals. C of x equals 400 there divided by 1. So c of x, I should put cost function, sorry. C of x is equal to 400. C bar of x equals 400. So that's the average cost. So that's the horizontal asymptote. So basically, the more wheelchairs you produce, the average cost for producing those wheelchairs approaches $400. So I'll write this down. The more wheelchairs you produce will lead to the average cost for producing each wheelchair to be $400. So basically, and I'll talk about the applications to the real world here. The more wheelchairs you produce, the average cost will be closer to $400. So if you produce if you don't produce as many, like 1,000, I know it sounds like a lot, but if you're a large company, it may not be a lot. The more wheelchairs you produce, though, the cost will be closer to, it'd be 400, so it'd be closer to 400. Now, what this means is kind of in a real world scenario, if you're a big business, then a lot of times big businesses can charge less for items because basically what they're doing is they've got, big businesses produce more product. And so as you produce more product, they can divide that cost by over more product, and they can do a smaller number. Where a smaller business, maybe that only produces maybe 1,000, it costs them a lot more per wheelchair. But if you're a bigger business that mass produces them, as you mass produce them, as long as you're doing it efficiently, you're going to be able to mass produce them at a much lower cost than a smaller business.